event.
That's all right.
Yeah. Hi guys. Are we all ready? Yeah. Yeah. So good day everyone. My name is CJ Jimuda. I'm currently the full stack data scientist and principal at Hybrid Data. At Hybrid Data, we're a little startup here in LA. So what we do is leveraging artificial intelligence, big data, industrial Internet of Things, and robotics technology to mine value from our clients' data assets. So what I'm going to be talking about today is optimizing photovoltaic energy yield with Elasticsearch and GraphQL. Just by means of just so I get a feel of the audience I have here. How many of you have an idea about what a photovoltaic cell is? Oh, great. Do you have some installed in your homes or something like that? Oh yeah, no one. Do you know if the power you're getting is coming off like a PV farm or a PV system? Do you have an idea about that? Oh, okay. So yeah, my plan today is just give you guys a sense of feel of what PV systems are and how you can use Elasticsearch to extract more value from it. As far as my talk today, I'll first of all give you guys a little bit about, just kind of rephrase the title of my talk, then give you guys an overview of what photovoltaic systems are, then talk about the technology stack that we use in being able to mine value from it, then give you a sense of feel of the insights you can get from it by using Elasticsearch and IIoT data, and also round up with conclusion. Like I alluded earlier, just to give Rush, what I want to give you guys a sense of feel is how you can optimize a photovoltaic energy yield from industrial Internet of Things data by leveraging Elasticsearch and numerous open source technologies. So numerous open source technologies, I mean like your GraphQL, your MQTT, you name it. So those are like the open source tools, and also your Apache VTL templating language. So just to give you guys a feel of an overview of photovoltaic cell. Whenever I confuse you, try to bring my attention. I have my background in electrical engineering, so I can go on and talk about it, but I'll try as much as possible to hit the high level. So basically you have like a PV array, which is like a photovoltaic cell. You have it, let's say, mounted on your roof. So you have an inverter. Your inverter, basically you're converting your direct current to alternating current, because the kind of currents you get from your sockets are alternating currents. You pass it through your shop panel. Well, again, the other side to it is for you to be able to maximize all the amount of energy coming from your photovoltaic cell. You also want to have a storage system. So that's why you see like the battery storage over there. But this snapshot basically just gives you a sense of feel of, so within like a photovoltaic system, for you to get the most benefit from it, you want to have like your battery storage. You want it to have its own independent inverter. You also want the inverter for the photovoltaic cell too to be independent. In that way you can take full advantage of the amount of energy you're getting from the sunlight. So really the push about renewable energy, why it's so great is that this chart here gives us a sense of feel of why it's so great. Because when you get like the most amount of power from a PV system, it's during like about getting close to midday to in the evening. So that's where this red hump you can see over there comes up, right? So the mismatch you see there is the renewable energy can keep on, supplying us the amount of energy we need to power our appliances. So what happens is for you to be able to cover up the mismatch you see there, because this is like what me and you, the amount of demand we get to about that point. you need something like, a storage system, like I alluded earlier, to store the power when you're not, using it, when you're not wasting it, so that you can later, put it on back on stream. But that also leads to other different challenges. So since the amount of electricity that you generate from your PV systems, they are being controlled by the sunlight. So you get to see all this type of spikes you see over here. Because, hey, maybe like in the morning there might be huge amount of sunlight for like 1 hour. The next 1 hour it's down. So that presents a lot of challenges in PV system. And that's also what makes it like tough for you to be able to accurately estimate how much energy yield is coming off your PV systems. So how we delved into this project was we had like a renewable energy client. They were estimating their PV system yields from third-party weather data. So with third-party weather data, it's not so granular enough that you can be able to accurately model your systems or forecast your system to give you a good sense of feel of, oh, okay, this is what my energy, like what your energy performance index might be, or what your PV energy yield might be. So based on that, the first thing we did was researching on the different variables that impact producing optimal energy yield from the PV systems. And out of all these different features, most of them are basically like weather, climate features. Out of like the cloud, all the weather, climate features, we realized that the temperature and the relative humidity had like the most significant effect of determining how much PV energy yield your systems could produce. So based on that, we advised them to install like IIoT sensors made up of humidity and temperature sensors in the location of those PV modules. Because previously their analysis were not based on any IIoT sensors within the location of the PV systems, but just general third-party weather data. So based on this, I'll give you guys a feel of how the stack looks like. As you can see Elasticsearch is over there. Why I put the dotted line around it is that it plays such a vital role, because it gives the intelligence that you can be able to analyze the data and say, okay, this is where I'm seeing like erroneous data from, or this is where I can get value from. Giving you a rundown of the stack. So you have your two sensors, your temperature and your humidity sensor. You feed it through your gateway device. From your gateway device, via like an MQTT broker on your AWS IoT call, you define what they call define different IoT rules, define different rules of ingesting the data to your Elasticsearch cluster, be it to an S3 bucket or a DynamoDB instance, or be it to like Lambda, just like Harry talked about earlier. It could be, hey, you want to start monitoring how your gateway is functioning, right? If it's getting like the different amount of, so you can do a whole lot of things from it. But again, if you notice, you see that I put like the very critical components of the stack like in red font. So the gateway is so critical because it's what connects your cloud infrastructure with the devices. The AWS IoT core is so important because it's what ingests data to the other different stuff. And the AppSync application, the AWS AppSync application, is what almost like a middleware. It's what fuses all the different data you get so that you can be able to get your live streams fed into any of your client applications, be it your web clients or your mobile clients, like in this case. So once you've designed the stack the way you want it to be, we use the serverless framework to deploy our workloads. Why we like it so much is, working with like YAML file. It's easy for you to like define different types of services that you want. You're also with the serverless framework. If you have you have your cloud infrastructure in GCP, it also allows you to like deploy your workloads to Google Cloud. If you have your infrastructures in, I think in IBM as well, it allows you to like, deploy your workloads on it as well. And depending on what environment, be it if you're writing your code in Go or you're writing your code in Python, you can actually, deploy your service with it. And if you're already used to like, writing YAML scripts with like Ansible and all of that different configuration tools, it's pretty like intuitive for you to pick it up easily. So this gives you a sense of feel. If you look at, below right here, right, you see the resources. So this is just us defining all the different resources, the IoT resources. The things is just the device, all the device resources. The streams is just a bunch of like the different database, Elasticsearch cluster that I alluded to, then also the authentication piece as well. And the great thing about it is once you've defined all these different stacks, you can just easily deploy it by running your serverless deploy function over there. And obviously it has to deploy successfully, right? So just give you like a sense of feel of how you define your, Elasticsearch stack, or how we define the Elasticsearch stack for this project. It's just similar kind of cloud formation template, you write. Either you're used to like writing it in JSON or you're used to writing it in YAML, but similar kind of thing, depending on, the amount of resources you want, depending on, how many instances you want, you can easily like, configure them there and deploy them. So this is just like part of one of the resources that you saw in the previous slide that I shared earlier. So now once you've deployed you've deployed these stacks and also you've deployed your Elasticsearch cluster. Now you want to be able to take the full advantage of the Elasticsearch cluster with a client. That's where you need your AWS AppSync, which has like GraphQL offerings attached to it. If we are conversant with like how the GraphQL ecosystem is, it's made up of you defining your schemas, defining your different queries, your mutations, just basically changing or updating your data, your subscription, your resolvers as well. So it's all made up of that. In my next slide, I'll just give you a sense of feel of the kind of schemas we define for. So this is just an example of you defining your schemas. You defining, so for this project, we're defining like the different inputs coming to our GraphQL, AWS AppSync application. Since we're interested in just the temperature and the humidity, the device serial number, the serial number, the model number, the client number, and also, so once that part has been done, now you're not defining the query I talked about in the previous slide, your mutations, your subscription, and exporting your schema so that you can use it in your AWS AppSync and definitions. I captured the dotted blue line there, just gives us a sense of feel of where we captured the query we will be calling for Elasticsearch from the AWS AppSync. So once that is set up, so I talked about, I showed the schema, the mutations, the subscriptions. Now the resolvers. The resolvers are very important because that's what fuses your request and your response calls. That's where the resolver handles it for you. So this is just giving you like a feel of we defining the different data sources. We had like, the data, some of the data in a DynamoDB instance. We had, the data too in an Elasticsearch instance. So we had to define those different data sources. Then write an Apache VTL, velocity templating languages, for us to be able to, for us to be able to get the request from the clients, and also for us to be able to respond back to it. This just gives us a feel of, for like the Elasticsearch. For the Elasticsearch, writing your Elasticsearch VTL template, which is part of the AppSync template we can see over here, for the request and for the response as well, how they were, how they were both, rated. So the magical thing, is that everything is being done on the serverless framework. So the serverless framework has this plugin called the serverless app sync plugin. With the serverless app sync plugin, that's what we use in defining, all the different resources we defined for the last slide I shared with you. And once you define it, like I showed previously, and you, send the command of SLS or serverless deploy command, you can be able to deploy all these different resources to the cloud. So once you've deployed all these different resources to the cloud, easily you can, since you already deployed your Elasticsearch instance, you can easily go there, get your Kibana endpoint on, you can view how your humidity data, to even see if it's streaming, if it's being ingested into your Elasticsearch instance. And once that is done, you can now do all any type of analysis, on the data on Elasticsearch. So some of for this project, like areas we saw like, huge amount of value, with working with Elasticsearch is, so the clients want to know, the renewable energy client wanted to know, hey, how can I be able to set alerts? So if my PV systems, if they're like, heated up, and I know like, hey, they're heated up, that means, I might not be able to get the amount of energy I want, so I better like, turn it up. Or if I have to do what they call like a demand response, like almost like load shedding. Shutting down, setting equipment they have in their facility, or instructing like, their different customers, shutting facilities. So these are the kind of things, with those alerts, they can be able to easily say, oh, okay, instead of depending on the weather, the third-party weather data they normally depend on, they can easily tell, okay, we need to like, shut this off or shut this on. Then that leads to you being able to accurately estimate what your PV energy yield is. Additionally too, you'll be able to estimate what your energy performance index is. So does anyone here understand what energy performance index is? Okay, so energy performance index is, it's kind of like two, so I'll explain what the energy performance index. Does anyone understand what the energy yield is, the PV energy yield is?
Yeah, so that's how much energy you're getting, like for a certain amount of the cell, right?
Yeah. But I'll put it like in the way it's been put out there in the renewable energy. So for the PV energy yield, it's more or less the energy, the AC, alternating current energy output you get versus the cost of your entire PV system. So from a managerial perspective, they want to know that. They want to be able to say, oh, okay, what's the lifespan of our assets? Do we change this like in 10 years or in 20 years? But for the energy performance index, it's just almost like operational, like day to day. It's more or less like your energy output versus what the specifications that came with your PV systems, what the output should be expected. And in practically, it's never 100%. There's always like, limitations to making it 100%. But with being able to have those, temperature and humidity sensors on site, it makes it possible, those erratic, ramping up and ramping down you see from, the PV, modules that I showed earlier, it makes you to be able to, reliably and accurately estimate and, mine more value from the data, the energy, from the temperature and the humidity data you get from the IoT devices. In conclusion, from me is, it's the best way to go about it is like we did, installing those actual sensors in the facilities, because you're using like third-party weather data wouldn't give you a reliable estimate of what your PV system yield will be. However, the PV system it's a convoluted system. If you saw the slide I showed earlier, it's not just only about the PV system. There are the inverters there. There are the circuit breakers there. There are the smart meters there. There are the, transformers there. So there's just like multitude of things. There are even your appliances to your loads. Your loads might be, messing up the entire grid as well. So they're just like in a multitude of different things. So it's not like it's all in stone that, hey, you can determine your energy yield from just the temperature and the humidity data. But it gives you, it reduces the more uncertainty for you of what variables are, affecting your prediction. Thank you. Yeah.
Okay, so when you're talking about yield, are your customers green power suppliers where they have to provide a certain amount of energy to a client and balance the energy that they're getting from the sun against energy that they've stored in order to balance out if the weather, if cloudiness means that your yield is going to be lower, you may have to increase your stored energy conversion in order to output to your client what their requirement is. And so if you are talking about a green generator provider, I can understand then the cost of their power, whether they're getting free power from the sun, or if they're consuming stored power that they had previously collected. So are your clients green power providers, or are they homeowners who are looking at graphs and seeing what their power against what the power company is crediting them for the power generated?
They're like a hybrid. If I understood your question correctly, they're like a hybrid power generation. Firm. So they deal with also like you've heard of like steam turbines. So they vary, what assets they want to, put on the stream, right, to generate power for them. So depending on, what they call generators. So the steam turbines, they use what they call generators. So depending on, hey, the efficiency of their generators, they might say, hey, they want to run their generators, their steam turbines for, let's run it for, since we have this amount of storage capacity and also the amount of sunlight we estimate, right? We compute both of them and, just, lump all of them together.
Okay, so they may be balancing natural.
That's when it's already got a generator, not just a solar panel.
Yes, they already have like.
So that sounds like an industrial use case.
Right,
Well,
so they may be using natural gas, oil, solar, and storage of some kind, geothermal possibly, to provide energy.
Geothermal too, yeah. So why I ask you all, like, do you know where your source of power is coming from? Is that I still feel that, I still feel like California seems like it's like kind of like the main state that, advocates for, okay, I think like it seems like they have like a quota that, hey, for every amount of electricity that's being traded in the grid in maybe LA County, it has to be 10% renewable or something like that, or 20% or 30%. But I feel like all around the country, a lot of people run on, even in California too, some people should run on like, you talked about geothermal, right? More than likely that might be like, up north where they have like the geysers, all these geothermal fields. And yeah, people should run on, some steam turbines, some gas turbines, yeah.
So because California is a grid, we just have a checkbox. Like, do we want to spend more money for green power, or do we want to spend less money for polluting another state with oil or with coal? That's all we have.
I would think there might be some power plants that you run on coal, maybe not in the US, but I feel like there's likely some, the whole essence is, even if you look at the PV system, is what? Heat. So whatever gas you're using is just like you're trying to, burn. For a steam turbine, right? You're trying to make it hot. For the geothermal, is okay. You already have the hot steam naturally, right? Then maybe now you might add, more gas. But it wouldn't be so much energy. The amount of gas you use for like a geothermal, you producing power from geothermal will be lesser than, hey, you're taking like, fresh water or boiling it, yeah. So it depends.
I'm trying to see if I understood correctly. You were asking about first PV performance index, right?
Yeah, the PV
If I were to
energy
define
performance,
it,
yeah.
I would say that's the ratio of actual energy that you produce
Exactly.
over the projected or expected energy that
Exactly.
you had estimated,
Yeah.
right?
Yeah.
Is that? And then the yield is actually like what is the cost of energy that you produce in relation to the cost of energy that is from other sources.
The financial piece. So that's why I said, it's
Is that
the
the way-
actual production over the system cost.
Is
So
that
how
the-
much, yeah.
Is that
Yeah.
an indication of what you're looking at, right?
Yeah, exactly. Yeah. And the expected you talked about, right, was more like, when you design these systems, right?
Exactly.
Exactly, yeah.
Bringing this discussion back to Elasticsearch, you
Okay.
mentioned that
Thank you.
use AI for training this stuff. I just want to go back to that piece, like how Elasticsearch helped you do the AI in helping this project.
So for the first piece, right? So the first piece is just basically you're writing like your filter queries, your range queries. You're saying you're defining, okay, the client says, okay, between this amount of temperature, right? Between this amount of time, send me an alert, send me an email, right? That's just simply like, simple queries. The reliable energy performance index. Now what you do, like, if you've heard of like the Elasticsearch, the analysis object, so you can write, setting computation. Like you had us talk about the definition of what an energy performance index is, right? So you write this computation. You already have those fields as metadata points fed into your cluster, right? So once you calculate it, you get, what your performance is over time based on all that. But what I can say is this, right? For the PV energy yield, it's more like machine learning task now, right? So now you have to your Elasticsearch, Elasticsearch have different plugins, right? You have your Spark plugin from Elasticsearch. So you're training your model, you've gotten all this different data, you train your model. I didn't want to be capturing that here because this is not like a Spark meetup and all that. A machine learning meetup is more Elasticsearch. And you can also see too there are different stacks that I didn't want to go really into. But yeah, for the PV energy yield, for you to be, estimating it, it's not just only based on the readings that you get. But one great thing, those two top, the funny thing is that even the proactive alerts, it's very valuable, like really valuable, to the clients, So, it just depends on how much value, but it's, and through Elasticsearch, you don't even have to add one.
So IoT has like bunch of streaming data coming like at a very high pace.
Yeah.
Was there any issues in Elasticsearch handling that data, like on scale and velocity perspective?
There was no issue. Everything just depends on, what Elasticsearch cluster, right, you're using, right? And, I just put up a vanilla stack. It could go different ways, you could, from your MQTT, you could be pushing this to a Kafka, Kafka cluster, Kafka broker. You could use a Kinesis Firehose, but this is just like, just making it as, plain as possible. But for our own use case, we didn't have to, delve into using like Kafka or using Kinesis Firehose, for pushing that, huge amount of data sets. But for the machine learning, we had to, spin up like EMR clusters, write Spark applications, Spark jobs to, run the modules on it.
How many customers have you talked about?
To be honest with you, that's you kind of like, in the back side, I mean, I would plan to, delve deeper into that. But what I could say is like, it's more like they serve more commercial customers, not residential customers. So commercial customers, it could be like, maybe like a gym facility, yeah. It could be like, yeah, but mostly like commercial clients, not residential customers.
Right, could you go back to the infrastructure slide?
Oh, sure.
I know you just said that. I was very curious. It sounds like you're using multiple data stores. What kinds of data do you find? Do you put into Elasticsearch versus into your other data stores, and how do you sort of merge them together?
Okay, so for the S3 bucket was just basically for us to be able to, because the kind of training we did was like a batch training, machine learning job. So it's just for us to be able to go back, read the data from the S3 bucket and train our models. And the predictions will push it to like the DynamoDB, databases. Then if I understood your question again, what was your question again?
No, I just said it seems like you're feeding your data. There's
Yeah.
that entry point from the
Yeah,
IoT,
yeah.
but it's going to different backends.
It is.
And getting collected right there around the red box on the right.
Yeah. So what happens is if you're using like, so if you were, there are different ways you can replicate the AWS IoT call. You could say remove the AWS IoT call from your MQTT. You already define your MQTT brokers, on an EC2 instance. You have your Kafka brokers, Kafka Connect. You connect it, you push your data to your Kafka broker, right? You won't really need this. So this is just almost like, your Kafka where you have like different consumers, right? So it's just in a nutshell, what this guy here is doing. Then the app sync is more or less, now you want to be able to accept the data, in real time and also offline mode. So what this does for you is by you linking all of them, as a middleware, you can easily stream data to be it your web applications, be it your mobile applications in this case. If you also saw over there too, captured Redux. So Redux is also for your client side, your state management as well. That's gonna, reduce the latency. In terms of the amount of data you get.
Then what's the frequency of the sensors? Is it the second? Or is it-
For this was like about for five seconds. Yeah, 5 seconds.
Any other questions? Thanks, CJ. We've got about another half hour. Any other questions about, anyone have problems they want to talk about, or anything about Elasticstack overall? That you guys might get a group to help answer, or? How many people are in production right now? And we said that most.